Okay, so for Al2O3, okay. So we have aluminium and oxygen. So the Al plus 3
Okay, okay,
and uh oxygen
2
2
minus.
minus 2 minus. Yes.
Total 2 aluminium ions and 3 oxide ions, right? Okay,
Yes. Yes.
okay. So then, uh, can you tell me what is electrolyte that I told you in the last class?
Electrolytes, okay. So is it a form of like energy? Uh I'm not really sure. I kind of forgot.
Electrolyte, I told you the solution which is a good conductor of electricity, which can conduct electricity basically, right?
Okay.
What is the charge on cathode and what is the charge on anode?
So cathode would be negative and anode would be positive.
Good. So in today's class, we are going to discuss what would happen if I'm going to electrolyze the molten compounds. If I'm going to electrolyze the molten compounds, I told you what is mean by the term molten. In molten, basically it's an ionic compound, but it's melted at a higher temperature.
Yeah.
It was solid at room temperature. It was solid at room temperature, but when I have melted it, so it's become liquid basically. So sodium chloride liquid. Liquid means this is molten. Melted at higher temperature. So I have taken a beaker. In that beaker, I have put some electrodes, obviously cathode and anode, connected to the, this is cathode and this is anode.
Okay.
Cathode
Wait,
is negative
sir?
and anode is positive, okay?
Yeah. Sir,
Yes,
can I go turn on my light 1 second?
sorry?
Can I turn on the light in my room? 1 sec.
Yes, 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 okay, okay.
Okay, yeah.
So then I'm going to take sodium chloride molten, NaCl liquid.
Hmm.
This is my electrolyte in this case.
Yeah.
When I have turned on the battery, so obviously the sodium chloride would be breaking down into cation and then anion. So first of all, you need to write this equation that I told you in the last class. Initially, you would be getting this Na plus and then Cl minus. Okay. So and then once you got this, so you have a lot of cations and anions in this beaker, in this container. After getting this, obviously, opposite charges attract each other. All the cations would go towards cathode and all the anions would go towards anode. So what would happen at cathode, at cathode, and at anode? At cathode, when Na plus would go towards cathode, it would take one electron and it would form this. And when Cl minus will go towards anode, it would give away one electron and it would form Cl. As you know that Cl is diatomic gas, so you are supposed to write 2. To balance this equation, you are supposed to write 2, you are supposed to write 2 over there. So in short, I can say that when you're going to electrolyze sodium chloride, so at cathode you would be getting sodium solid and you would be getting chlorine gas. What you would observe at anode, yellowish green gas would observe, yellowish green gas will observe, and at cathode, and at cathode, grayish white solid is deposited at cathode basically. Okay, so this is the thing that you would observe at cathode and at anode. So remember, the main thing is to know, okay, what you would get if you are going to electrolyze sodium chloride liquid. Okay, same goes with magnesium chloride. Same goes with magnesium chloride. This is also an ionic compound. It should be in the form of liquid, because in the form of solid, ionic compounds are bad conductor. I told you in the last class that why they are bad conductors, and then you told me that the ions are not free to move in the solid state. But when the ionic compounds are in the liquid state, so the ions are free to move, so they can conduct electricity. That's
Yeah.
why we are supposed to take all the ionic compounds in the liquid state, and also you can take in its aqueous state. So yes, you have to form three equations. Number one, this equation, then at cathode, then at anode. Yes.
Okay. So for MgCl, so the first one would be Mg. So for the first equation, it would be Mg minus plus Mg plus, and then it will be chlorine chlorine wait no Mg2 plus and Cl minus. Because yeah, okay, and then at the cathode, um magnesium with plus would magnesium 2 plus would react with two ele- two electrons which are negatively charged to form magnesium, and chlorine would react with wait, chlorine is diatomic, right?
Chlorine is diatomic, yes.
Okay, so chlorine would react with two negative electrons to form Cl2.
Okay. So first of all, remember, magnesium chloride would give you two ions, Mg2 plus and 2Cl minus. Okay.
Mm-hmm.
And then at cathode, magnesium 2 plus would gain two electrons, would form Mg solid. And at anode, Cl minus. Obviously, it gave us two Cl minus, would lose two electrons and would form Cl2 gas. Okay,
Okay.
easy? Yes.
Yeah.
And then if you have this, then what you are supposed to do?
Um. Oh, okay. So magnesium. All right. So magnesium 3. So okay, it would be Mg 2 plus and nitrogen minus 3. At the cathode, magnesium would react with two electrons to form magnesium in its solid state, and at the anode, nitrogen would is diatomic, so it would react with two negative electrons um, to form N2 gas.
Write it down and then send me.
Oh, okay. I need my iPad. It's like right there. I'll go get it.
Yes.
Yep.
At cathode, then
Wait.
at anode, and then overall equation.
Okay. Yeah. Um. So 3E. Okay. Not sure if this is right, but I think it is. I'll send the full equation. So what's the full equation? It'll be okay. Yeah. Mg and Mg3 and 2 Mg2 plus and then and I'm sending it now here.
Okay. Mm.
One second, I need to get WhatsApp on my iPad so I can send it to you. Okay, yeah, I sent it to you. I
Okay.
think you should have got it.
No.
Okay, let me send it again. I sent it now. Is it still not going?
Yes, I got it.
Or The first
You
one.
have, okay, the first one is correct. Okay, then the equation is not balanced because in the product side 2n and in the reactant side you have 3n.
Oh yeah, yeah, yeah. True. I forgot
Yes.
about that. Okay.
So the first one is that you did like that,
Mhm.
Mg2 plus,
Mhm.
then N3 minus, then at cathode, Mg2 plus, 2 electrons, then Mg, then N3 minus,
Yeah.
would lose 3 electron, would form N. This is diatomic. I'm supposed to write 2.
Do we need
It
to
should be
mention this?
2.
Do I need to mention the state?
State symbol. No,
Yes.
no, no.
Okay.
Obviously, it's a gas. And then, obviously, if one nitrogen is going to lose 3 electrons, so two nitrogen atom would be losing 6 electrons. So I'm supposed to write 6 over there. So now this is
Oh.
balanced equation.
Okay.
Okay? Yes. So then we are supposed to add them together. I would be doing later on. First of all, you must know, okay, whenever you have any cation or anion, so what you would be doing if they are going to add cathode or and if they are going to the anode. Now let's suppose we have sodium oxide, Na2O. Yes, it's also the molten. Right now we are doing only the molten states.
Oh, okay. So, oh wait, wait, does it matter? What does the equation change whether it's molten or not?
Sorry,
Does the does the equation change even though it's molten, or is it fine, or does it
the
matter?
the product would change if you have molten or aqueous. That's why I'm saying first of all we are doing molten, right?
Oh, okay. How do we do molten? Did we already do molten? Was that molten?
Hmm?
Was the magnesium nitrate?
Yes,
Uh,
it was molten. Yes,
okay, that's easier. Wait, is this aqueous?
it's this is molten.
Oh, let me do it and send it. Na2O in the liquid state. Okay. Oxygen is diatomic, so we'll have a 2. Cathode, it will be Na plus E negative become Na, and that's anode, it would be oxygen O2, 2 negative 2 plus, so negative 2 times 3, so E negative. Yeah, I think so. Then okay, I'll send it to you now. I'm sending it to you now.
Okay. I didn't get.
1 second. I'm almost done. Yeah, yeah, I send it. Okay, I'll send it now. WhatsApp device. I just need to link the device. Okay, so then, yeah, I sent it now. Did you receive it? How about now?
Yes, okay, I got it.
Yeah.
So Na plus plus E minus 4 electron, then O2, then O2, then O2. Okay, good. So you did Na2O, then into 2 Na positive, 2 negative, then at cathode,
I don't know
2.
if the 4e negative is correct, but I think it is because 4 electrons.
Let's see. So O2 minus would lose 2 electrons to form O2
Mm-hmm.
because this is diatomic. If one oxygen is going to lose 2 electrons, so to balance this equation, I need to write 2 over there. Then 2 oxygen would be losing 4 electrons.
Yes, that's correct. Then,
Yes. So before
then
going to do electrolysis, you must know these all the things so that you can say when the examiner would be asking, okay, what would be the product at cathode and what would be the product at anode. Okay. Okay.
yeah.
Then we have uh, mm, sodium chloride aqueous. Sodium chloride aqueous. Aqueous means that I have dissolved the sodium chloride into the water. I have dissolved sodium chloride into the water. Now the thing is that K, like how much water did you take? If you have taken a lot of water, so the solution would be called like the dilute solution. And if you have less amount of water and more amount of salt, then it would be called concentrated solution. So in this aqueous, you may have two conditions. Number one, you may have two conditions. Number one, dilute and then concentrated. So for dilute solution, more solvent and less solvent. Okay, more water. Solvent means more water.
Okay.
Yes. Let's suppose I'm going to tell you that this is dilute sodium chloride aqueous.
Okay.
So, you know, when we were doing the molten case, in which I told you that there is no water, okay? So
Yeah.
when there is no water, so obviously you did just like that, that when you are going to break down NaCl, so it would be giving you the two ions, this and
Mm.
this. But now the problem is that we have water as well, along with sodium chloride.
Okay.
Obviously, when you would be passing electricity, it would affect water as well.
Mm-hmm.
You cannot expect that only the sodium chloride would be breaking down into the respective ion, but also the water would be breaking down.
Like H2O, yeah.
So, exactly. So, after breaking down, after providing electricity, you would be getting the total four ions. You would be getting the total four ions. Now,
Please,
then
separately or together?
exactly, you have
Okay.
to show it separately, right?
Yeah.
Now, remember, right now I'm telling you, but later on I would be telling you the reactivity series only for today. Remember, only group 1 and group 2 metals would not go always in aqueous state. Like, let's suppose if you are going to take molten one, so obviously, molten may, you can say a metal would go towards cathode and non-metal would go toward anode. But the thing is, this is aqueous. In aqueous, all the time you have to remember that group 1 and group 2 metal will never go. I'm writing it. Group 1 and 2 metal will never go to cathode, okay?
Okay. So
Yes.
group one metals will never go to the cathode.
Hmm.
So like magnesium won't go cathode, it will go. Oh, no, magnesium would. Only group one metals, or is there any other?
Only group 1 and group 2 metals.
But what about magnesium? I did it in cathode, no? If we go back up on the thing.
Sorry?
We did magnesium in cathode though, if you go
No,
back up.
no, no. It was molten. It was molten. That's what I'm
Okay.
saying. It's
Oh,
not
okay.
molten. It's not molten. It's in aqueous state, right? It's
Ah,
not molten. Remember.
yeah.
Yes. So only H plus would go towards cathode. It's also diatomic, so you are supposed to write 2 over there.
Yeah, yeah.
Then at anode, you have the two things. Number one is this, number two is this. The two peoples are ready to go towards anode because both have negative charge. When both have
Mm-hmm.
negative charge, then you have to decide what we are supposed to do. Obviously, you have the dilute solution. Dilute means more water and less NaCl. Am I right?
Yeah.
Am I right? Yes.
Yeah.
More water means more OH minus. So OH minus would go towards anode. Remember,
Mm-hmm.
it would form this. It would form. You're supposed to memorize this equation. A lot of time, frequently you would see this equation. Frequently you would see this equation. So it's one time investment that you're supposed to memorize this whenever you're going to have OH minus and it would be going toward anode. So it would be giving you one electron. Then I'm going to balance it. This is four, and this is two. You're supposed to memorize this because in the next, all the classes we would be doing, we would be using this equation.
For water, this is for water, right?
This is for OH minus. Whether the OH minus is coming from water, whether it's coming from any of the compound. Let's suppose the compound may be sodium hydroxide. Okay.
But I should memorize it because water is probably most frequent, right?
Yes, exactly.
Okay, fine. I'll take a
Okay.
picture of it. Wait, 1 second.
Yes.
Let me just take. Yeah. Okay.
Yes. And so this is your full cathode and anode equation, right?
Yeah.
Yes, do this
Mm-hmm.
and send it on the group, please. I'm going to perform the namaz, okay?
Yeah.
Send it on the group right now.
MgCl2.
Aqueous, right?
All right. Okay.
Okay.